Hype the planet! Hype the planet! Shut up and get it!
We're in.
Shall we play a game?
How about global thermonuclear war?
All right, is my avatar going to show up? Here we go. Okay. All right, everybody. We're doing HackerFrogs co-working right now. So we're going to be doing some co-working, some co-learning. I'm going to be teaching myself how to code in C with this online course over here. And I might as well, I told myself I might as well do some live streaming while I'm at it, because I might be studying for like 2 or 3 hours, and it's always fun to have chat alongside with me. Okay. A C refresher is never wrong. Okay. SysOS Master, hello, nice to see you here, and hope you're doing okay in the morning over where you live. And Sathya, hello, nice to see you here. And it's morning for you. I'm guessing you are either in Europe or in Asia. I'm not too sure which one that might be. Spam all the emojis. That's what we aim to do over here. All right, so let's get down to business. I'm going to be studying and talking through my course over here. If you want to use that as background noise for your own day, that is completely fine. So what we're going to do is we're going to put 2 hours on the clock, and I'm going to study for 2 hours. And if you have any questions about cybersecurity or tech, let us know in the chat, because I'm happy to talk to everybody. Asia, India, awesome, awesome. How do you say hello in Hindi? It's namaste. Hello, nice to see you, Satha. And yeah, so we're just going to be learning C over here. If you want to take the same course I'm doing over here, it's C Essentials Part 1 from edubay.org. Here's the link. And let me go ahead and get started. Okay, so what are we doing in this module? So in this module, we're going to be, well, let's make this bigger. Hopefully everybody can read this. In this module, we're going to be learning how about floating point values in real life and in C, arithmetic operators, priorities and binding, post and pre-incrementation and decrementation, all right? Operators of type OP equals, the char, character type, and ASCII code, character literals, equivalence of integer and character data, comparison operators, conditional execution in the if keyword, the printf and scanf functions, that's great. And so this is module number 2 of our course. I think there are 8 modules in the course, so 8 chapters. And this is an interactive course. I'm going to be learning, and if you want to keep me on in the background, then that's no problem at all. So we're just going to play the background music in the background as well. Hopefully it's not too loud. Let me see what the volume is like. Maybe that can be a little bit softer. All right, and let's see. Sat says Vanakkam, and in Tamil, India is a multilingual country. Yeah, there are several languages spoken in India. I think some of the major ones are Hindi, Punjabi, and Tamil. And maybe one other. I'm not too sure, but those are the 3 major ones, right? Okay, so let's get started with this section. All right, I need to log in apparently again. Let's do that. Could not verify request. Please refresh the page and try again. Okay, so I'll reset the page, and then we will log in. Okay, so this is the C Essentials 1 course that I'm taking over here. And let's go ahead and resume the course. So this website over here has a bunch of different coding courses available, such as Python Essentials, they've got C Essentials, they've got C, I think they also have JavaScript Essentials, so if you're looking to learn a programming language, it's a pretty good place to learn because these courses are pretty in-depth. Okay, so we will continue. So let's learn about these floating point numbers. In our first lesson, we became acquainted with the concept of the data type and learned that one of the basic types known in the C language is the integer named int. So now it's time to talk about another type which is designed to represent and store numbers that, as a mathematician would say, have a non-empty decimal fraction. So we're talking about numbers that are accurate to several decimal places. Okay, Satha says there are more than 120 languages, but 22 are recognized ones. Wow, I didn't know there were so many languages. And I didn't know there were so many recognized languages as well. But, I mean, I'm here to learn too, about culture as well as about tech. Thank you very much for letting me know about that, Satha. So floating point numbers, so in real life and in C language, thank you very much for following on Twitch, Kilobyte808, thank you. Much appreciated. Let's go back to the values that we quoted a moment ago. 2.5 looks normal when you write it in a program, although if your native language prefers to use a comma instead of a point in the number, you should ensure that your number doesn't contain any commas. The compiler won't accept it, or in very rare but possible cases, will misunderstand your intentions, as the comma itself has its own reserved meaning in the C language. If you want to use the value just 2.5, you should write it down as shown in the picture. Note once again there is a point between the 2 and a 5, not a comma. Okay, so as you can imagine, the value of 0.4 could be written in C as 0.4. Comrade Soul, hello, nice to see you here. Okay, and thank you very much, Satha. If you have any questions about cybersecurity or tech, let me know and I'll try to answer them as best I can. Of course, I'm not really an expert, I can just offer my own perspective. Okay, so don't forget this simple rule. You can omit 0 when it's the only digit in front or after the decimal point. In essence, you can write the 0.4 as shown on the right. You can omit 0. You can omit 0 in C, so you can just do 0.4. That's interesting to know. Ow, modern C. Modern C? I mean, what are the different types of C? I'm not really very well versed in this, SOS Master. So for example, the value 4.0 could be written as 4 point. Oh. 4 point means 4.0 without changing its type or value. Note the decimal point is essential in recognizing floating point numbers in C. Look at these two numbers, 4 and 4.0. So I'm sure they're going to say that this is an integer and this is a float. For you, that might be exactly the same, but the C compiler sees these two numbers in a completely different way. So 4 is an integer, so these are whole numbers. Okay, and 4.0 is a double, representing double precision floating point numbers. They have 15 decimal digits of precision and can easily be assigned to floats. So for example, single precision floating point numbers which have 6 decimals of precision. 6 decimal digits of precision. We'll tell you more about the difference between doubles and float data types soon. So we can say that the point makes it a double, don't forget that. Okay, many variants of C, almost more languages in India. Really? Okay. Okay, Satha AX, okay, it's another account. Oh, nice. Nice, you got multiple YouTube accounts. Awesome. Okay, so we've got somebody playing golf. 4 point. Okay. So you might want to use any numbers that are very large or very small. You can use scientific notation. Take, for example, the speed of light expressed in meters per second. Written directly, it would look like this. So it's 3 and how many zeros? 1, 2, 3, 4, 5, 6, 7. That's 8 zeros. Okay, so that's 1,000. That's million. So 300 trillion meters per second. 300 trillion meters per second. It sounds like a very fast speed. To avoid tediously writing so many zeros, physics textbooks use an abbreviated form, which you have probably seen. So 3 to the power of 10 times 8. 3 to the power of 10 times 8. 3 to the power of 10 to the power of 8. 3 times 10, oh okay, to the power of 8. So in the C language, the same effect is achieved in a slightly different form. Take a look. So it's 3 exponent 8. So the letter E, you can also use the lowercase letter e, it comes from the word exponent, is a concise version of the phrase times 10 to the power of. So 3 times 10 to the power of 8 in this case. Okay, the exponent, the value after the e, must be an integer. The base, the value in front of the e, can be an integer. So we could do 3 point something e something something, right? Okay, so it says a trillion has 12 zeros in standard numerical form. I think it's written as 1. Okay, yeah, that's a big number. So it's not a trillion. So after, oh, billion, right. So after million is billion, million, billion, and then trillion. So these 3 numbers are the thousands. These are the millions after that. And then afterwards, these are the billions. So 300 billion meters per second. Thank you for correcting me on that. I don't usually deal with numbers that are that big, but got to get used to them. Okay, so next section. Let's see how we use this conversion to record numbers that are very small in the sense of their absolute value, which is close to 0. A physical constant called Planck's constant, as denoted as h, has, according to the textbooks, the value of 6.62607 times 10 to the power of negative 34. Okay, so if you wanted to use it in a program, you could write it this way. So 6.62607 e minus 34. Are you with us so far? Well, hopefully. Cybersky says, I completed C coding in my college semester 1, but can you tell me where C coding is used in cybersecurity? So C coding is used in cybersecurity as far as exploit development is concerned, as well as reverse engineering. So a lot of, let's talk about this. So C for cybersecurity. So binary exploits can be written in C or C++. Reverse engineering requires knowledge of C because reverse engineering software, what is the term again? It decompiles. It decompiles binary instructions to C-like code. So these are the two major areas of cybersecurity that can use C. So reverse engineering and binary exploitation or malware development. Those are the two types. Okay, let's continue. C has a 1 to 100 relationship to assembly, and assembly has a 1-to-1 relationship with machine code. Yes, thank you for letting us know about that, says OS Master. And welcome to the stream, Cybersky. Nice to see you here. Sathis says buffer overflows, stack overflows. Yeah, you'll let's see. So let's go back to floating point values. I already know what a variable is and how you can declare an integer variable. So it'll be no surprise to you that you can declare variables of the floating point type. This can be done using the keyword double for floating point numbers of the type double and the keyword float for floating point numbers of the type float. So I know for a fact that one of these is more precise than the other. And you want to be, because you want to be efficient with your use of memory, you want to use the one that is appropriate for the job. So if you want to be more precise, I think floats are more precise than doubles, but I could be wrong. So knowing that we can declare two floating point variables, we're going to declare one named pi. We can't name it the Greek letter because, as you know, the C language does not allow variable names written with Greek letters, and the other one named field. We don't need a high degree of precision for our calculations, so we're going to, so float is the less precise one. Okay, doubles take 2 times float size. Thank you for letting me know about that. Okay, so float, pi, and field. So I guess if we want it to be less precise, we can use float. Or if we don't need it to be precise necessarily, we'll use float. Okay. So as you can see from the syntax's point of view, the difference in declaring integers and float variables is quite small. So int I float x, I equals 10 divided by 4, and x equals 10.0 divided by 4.0. So the difference is significant in terms of semantics. Whoa, that's kind of loud. Which is shown by the example on the right. With a little anticipation, we can say that the symbol, more precisely the operator, which performs the mathematical division, is a single character slash. Take a look at the code. You might find it a little surprising, however, that the value placed inside the variable I is 2. Yes, just 2. While the variable x is equal to 2.5. Look at the example carefully because it illustrates a very important difference between the two data types. Okay, so I is equal to 2. So we would expect it to be 2.5, but because I is an integer, we have to round down to the nearest integer, which in this case is 2. But because x is a float, it can be precise, and it can be rendered as 2.5. Okay, so what happens when we're forced to convert integer values to float values or vice versa? The transformation from type int into float is always possible and feasible, but in some cases it can cause a loss of accuracy. Consider the example below. So int I float f, I equals 100, f equals I. Okay, so we expect that f, because it's a float, will be 100.0. So after the second assignment, the value of the variable f is 100.0 because the value of type int 100 is automatically converted into a float, so accurate to some degree of decimal point. The transformation affects the internal machine representation of those values, so computers use different methods for storing floats and ints in their memory. Let's consider the opposite situation now. As you've probably guessed, these substitutions result in a loss of accuracy. The value of the variable I will be 100. 25 hundredths has no meaning in the int world. There's another aspect of the operation. Converting a float into an int is not always feasible. Okay? Integer variables, like floats, have a limited capacity. Integer variables, like floats. How are floats integer variables? Okay, let's just continue. They cannot contain arbitrarily large or arbitrarily small numbers. For example, if a certain type of computer uses 4 bytes, that is 32 bits, to store integer values, you're only able to use the numbers from the range of negative this really big number to positive this really big number. Let's see if I can puzzle this out. So this is thousands, this is millions, this is billions, and this is trillions. So it's like 2 trillion something? 2 trillion, 147 billion, 483 million, 647. Okay, so we've got integer I, float f, f equals 100.25, and I equals f. So I'm assuming that the 0.25 is going to get cut off in this case, but I'm not completely sure. That is 2 billion. That is 2 billion? Hold on. I'm apparently I'm really bad at counting numbers. Okay, so this is thousands. This is 100,000s. Is this thousands? 100,000s. Oh yeah, I forgot the 100,000s. Okay, thousands, 100,000s, millions, billions. So 2,147,483,647. Okay, it's 32 bits, so it's 2 to the power of 32. 2 to the power of 32. Okay, the I variable is unable to store such a large value, but it isn't clear what will happen during the assignment. Certainly a loss of accuracy will occur, but the value assigned to the variable I is not known in advance. In some systems, it may be the maximum permissible int value, while in others an error occurs, and in others still, the value assigned may be completely random. So this is what we call an implementation-dependent issue. Implementation-dependent issue. It's the second and uglier face of software portability. Okay, so I guess the easier way to do it, what's happening here? Int I, float f. F equals 1 to 10 to the power of 10, and I equals f. So this float, when converted into an integer, something bad is going to happen because we've got too many digits. So if we're to calculate this, I need to get better at counting. Okay, so So let's see. What was it again? 1 times 10 to the power of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's... These are the 100,000s. This is... So this is the millions right here, and this is the billions. So it's 10... 1 times 10, so it's 10 billion? There should be 10 billion, right? So 1 times 10 to the power of 10 zeros. Okay, so this will not work because this is supposed to be a 32-bit integer. Okay, so we've got a little coding exercise here. So, level of difficulty easy. Objective, familiarize the student with fixing errors in a program, floating point numbers printing on the screen. So check the program in the editor, find all possible compilation errors and logic errors, fix them. Your version of the program must print the same results as the expected output. Before you use the compiler, try to find the errors only by manual code analysis. So expected output, the value of 7 is 7.60. And let's see, the value of 8.5 is 8.5 and then 5 zeros. Okay, so what is the code? So int main, we're not returning, we're not giving any parameters. Printf, the value of 7 is float. Float 7.0. So this has to be a 7.0. Do we need to specify how many zeros to put in here? Or do we just put in 1 0 and the compiler will do the rest? Okay, int has only 2 parameters on most systems. It's the main entry point. So yeah, main is... I'm not too sure about parameters for the main function. That's what I'm here to learn. And the value of 8.5 is... So F for float, and then 8.5. So let's see what happens if we just run this code as is. Okay, you should write your code inside of the int main. Okay, you're learning coding today, hacker boy. Yeah, the code guy. Hello, nice to see you here. You're the code guy, so you must know a lot about coding. What coding languages do you code in, the code guy? Let us know. Okay, so if we just run this code... Yeah, this is exactly what they're looking for. The expected output is the same. So I guess they're going to automatically include the zeros to as many points as they can, because this is a float data type. Okay, the code guy says, I use JavaScript. Awesome, awesome. Yeah, JavaScript is very important for web applications. So JavaScript, TypeScript, Next.js, React. Awesome, awesome. Okay, sysOS says argc is the amount of entries in argv. Is that a parameter that the main function usually takes, or is that something you can put in the parameters for the main function? Okay, we've got a break going on Twitch right now, so I guess I'll take a little water break, and I'll put on the birds. So here are some birds. And we'll be back in about 60 seconds. But enjoy the birds and enjoy the music. I thought the bird would come back, but he doesn't come back. Okay. Anyways, let's get back to the co-working. Okay, so apparently we've outputted the exactly what they're looking for, so we can move on. Okay, SysOS Master is giving spoilers. Are there spoilers? The main the main function. So integer argc and character pointer argv body, okay, where argc is the amount of entries in argv. Okay, Sathi says there's something called Zeal PHP, check it out. Zeal PHP. And let's see. The code guy, yeah, so you're doing JavaScript, TypeScript, Next.js. That does seem like some front-end language stack. Is that what you do the code by? Full stack. Oh, okay, okay. Awesome, awesome. All right, let's move on to the next section. Okay, level of difficulty easy. Familiarize a student with fixing errors in a program, floating point numbers printing on screen. Okay, check the program in the editor, fix all the compilation errors. The value of 9 is 9, and the value of 10 is 10. So we're still dealing with floating point numbers. So float 10 value equals... How many zeros are they putting in here? 1, 2, 3, 4, 5, 6. Okay. And we're looking for 10 value over here. And the value of 9. I mean, I'm pretty sure... I wonder what happens if you put 09.000. Will it fill the rest in, or is it going to result in something weird? Okay, we'll try running the code. So, okay. So 09 is the same as 9, as far as the compiler is concerned. And it looks like the right number of zeros have been output as well. So this is 6 zeros, and this is 6 zeros. Okay, if you want to learn in depth, you should boot dev. Most programmers do it. If you want to learn, the code guy says, if you want to learn in depth, you should do boot dev. Most programmers are doing it. I mean, I'm learning C as part of my cybersecurity training, not necessarily to become like a developer, but boot dev. I think boot dev is like a paid service. As far as like learning programming languages is concerned, I prefer to use like free services because I can recommend them to beginners, especially people with not a lot of money. Anyways, we'll move on to the next section. I think we've finished this one. All right, so here's another coding problem. So check the program in the editor, fix all the problems, okay? The value of half is 0.5 and then 5 zeros. And the value of pi is, let's see, how many digits are here? So this is also 5 decimal places. Okay, so half value is 0. Should be this, right? And then pi value is, and they've separated these. You can't have spaces in here. So okay, half value has to not have spaces, and pi value also needs to not have this underscore. And I think that's it. All right, we'll try running it. Return 0 int main. Okay, so there's something wrong. So line 5. Oh, okay. Yeah, there's some extra stuff in here. Let's get rid of this. And I think this should be fine, okay? No? Still not good? So half value is here. So this is a float. And pi value, just make sure that the spelling is correct. Oh, there are too many, maybe there are too many digits. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there are too many there are too many digits for a float here. So I guess what we need to do is we just need to edit this so it's the correct number as the expected output. Okay, Henky Ludwig, hello, nice to see you here. Nice to see you here. By the way, what do you think about manual coding or using vibe coding? I mean, you should be competent at whatever language you're using to do vibe coding. You shouldn't not know coding in the language that you're doing your vibe coding in. Because if your vibe coding comes across errors or has some sort of you have to debug the code yourself, you can't rely completely on the AI to do your debugging for you, because that can be a little bit too much as far as reliance on the AI is concerned. Okay, so try running it. No, it still doesn't want to. It still doesn't want to run. What's wrong here? So 3.141593, 3.141593. So this is a float called pi value, and this is a float called half value. It looks like everything here is okay. I guess we need to take a look at what these error messages are. Incompatible implicit declaration of built-in function. Oh, we're missing the header. Yeah. Okay. There's no standard IO, so we need to include standard IO.h. That's interesting. That's interesting. I mean, I just kind of assumed in all the previous examples. Okay, let's run it again. Now we've got a different one. Implicit declaration of function printf. Printf, which what do we need to include for printf? See printf. Printf include. Thank you very much, Hackserbyte, for raiding with a party of 5. Hello, raiders, and nice to see you here. My name's The Shy Hat. I do cybersecurity content on Twitch and on YouTube. And tonight we're just doing a co-working stream, or co-working stream, co-learning stream. We're learning how to code in C. Okay, standard.h header. So it includes standard.h. Yeah, I mean, what's wrong with what I've got right now? Implicit declaration of function printf. So the value of, what am I missing here? Standard.io.h. Let me double check that. Include, hashtag include, stdio.h. stdio.h. And thank you very much for following on Twitch, Evolving Fetus 1. Hello. Hackserbyte, what were you all getting up to on your stream? No space between include and standard IO. So like this. And it's still, oh, no, now it's working. Okay. It worked for the last 2. Anyways, I think we can put like a space between this, right? Yeah, okay. It's good to know. Thank you for following Places Everyone on Twitch. Thank you very much. Hey, Shy Hat, you're on pretty late. Easy. Hello, nice to see you here, Sick in the Mind. Yeah, we're just up late. We're doing some study. I might do like 3 hours of study. I'd like to stream more, and I'm going to be studying C language anyways, so I might as well do it on stream, so that everybody can tell me when I'm getting something wrong. I can also ask people in the chat to help me debug my code. All right, we move on to the next section. Okay, so yeah, this is the same as the expected output. Okay, move on. Okay, operators. I can't believe we haven't been talking about operators all this time. An operator is a sign of the programming language which is able to operate on the values. For example, one assignment operator is the equal sign. You already know that it can assign values to variables. Let's take a look at some of the other operators available in the C language and learn which rules govern their use and how to interpret the operations they perform. We'll begin with the operators associated with the widely recognizable arithmetic operators. The order of their appearance is not accidental. We'll talk more about it in the end. Okay, so we got plus, minus, slash for division, and then star for multiplication. We also have the percent sign for the modulo operation. So multiplication. An asterisk is a multiplication operator. If you take a look at the code, you'll see that the variable k will be set to value of 120, while the z variable will be set to 0.625. Okay, so what do we have here? So we've got integer ijk and float xyz. We set I as 10, j as 12, k as I times j. So that would be 10 times 12. X is 1.25, y is 0.5, and z is x times y. Okay, so that would be 1.5 times 0.5. So that, my math is really bad. What happens when you multiply 1.25 by 0.5? So this is like division, right? So if we multiply by a decimal number, or if we multiply by a fraction, then we divide. So it would be 0.75? 0.625. Okay, multiplying by less than 1 is a division. 625. I think they tell you up here. So yeah, so this is 0.625. So 0.625 times times 2. Anyways, we'll move on. So division. A slash is the divisional operator. The value in front of the slash is the dividend. The value behind the slash is the divisor. Consider the snippet of the program. Of course, k will be set to 2, and z will be set to 0.5. So ijk, x, y, z. So let's see. I and j are set to 10 and 5. K is I divided by j. So I divided by j, so that would be 2. And then we've got 1.0, and then 2.0, and then we've got 1.0 divided by 2.0. So 1 divided by 2, and 0.5. Yeah, okay. And then we've got division by 0. So if you probably guessed, division by 0 is strictly forbidden, but the penalty for violating this rule will come to you at different moments. If you dare to write something like that, a judgment will be issued by the compiler. You may get a compilation error and you won't be able to run your program. So float x equals 1.0 divided by 0.0. So in the following example, the compiler won't tell you anything, but when you try to execute the code, it may terminate abnormally and produce unreliable results. You'll be informed of this sad fact by the relevant message, and then nothing else will happen. Okay, so I mean, we can try to run this inside of a C online C compiler. Online C compiler. We'll see what happens. Okay, so we can just put this inside of our code like this, and then we will run the code. Where's the run button? There it is. finish program with exit code 0. Oh, so the compiler didn't yell at me. I mean, I guess what we can do is we can just try to print this out. Printf and we print out a float. So it's %f -n and put it between this, right? And then we y like that. Okay, and then we'll try running this. INF, so this is infinite, I think. So this particular compiler doesn't crash the program, but it does give you in INF. I guess that stands for infinite. Okay, move on to the next thing. Addition. The addition operator is the plus sign. Okay, and let's look at the snippet of the program. So this is pretty straightforward. So 100 plus 2, and then we've got 1.0 plus 0.02. Okay, and then we got subtraction with the minus sign. Although you should note that this operator also has another meaning. It can change the sign of a number. So minus can subtract a number, and it also can indicate that a number is negative. So this is a great opportunity to show you a very important distinction between unary and binary operators. In the C language, there is also one ternary operator. We'll talk more about that a bit later. So as usual, let's get ourselves acquainted with the code snippet. You can probably guess that k will be equal to -100, while z will be equal to 0.0. Okay, so it's 100 minus 200, so that's -100, and 1.0 minus 1.0 is 0.0, okay? CyberSky says that was a modern C compiler. If you write that in a normal compiler, it'll give you a runtime error. Oh, okay. It's good to know that there are differences between the different compilers, and that not all the compilers are going to give you the same stuff. Okay, and we will move on. Unary minus. In subtracting applications, the minus operator expects two arguments. The left, a minuend? I'm not too sure what this is in arithmetic terms. And the right, a subtractend. A minuend and a subtractend. For this reason, the subtracting operation is considered one of the binary operators, just like the addition, multiplication, and division operators. But the minus operator can be used in a different way. Take a look at this snippet. So if you probably guessed, the variable j will be assigned the value of 100. We use the minus operator as a unary operator, as it expects only one argument, the right one. So this is I guess this is a unary operator if you put it before a number like this. And it's a binary operator if you use it with another number. Okay, and then we've got unary plus. So the same dual nature is expressed by the plus operator, which can be used as a unary operator. Its role is to preserve the sign. So if we take a look at this, so integers I and j. So I is 100 and j is plus I, which means it's I as a positive digit. So although such a construction is syntactically correct, using it doesn't make much sense, and it would be hard to find a good rationale for doing so. Okay, and we'll move on. Remainder. So the remainder operation, or modulus, as it is often called. So I thought this was, I've always called this the modulus operator, or the modulo operator. Although I guess it's good to get the exact terminology right. So this is modulus, or remainder. It's quite a peculiar operator because it has no equivalent among traditional arithmetic operators. Its graphical representation in the C language is the following characters, so the %, which may look a bit confusing. It's a binary operator and both arguments cannot be floats. So we can't use, so when we use the modulo operation, we can't use it on floating point numbers. Okay, so we've got integers I, j, and k. I is 13, j is 5, and k is I modulo j. So I 13 modulo j, so that would be 13 divided by 5 and return the remainder. So that would be 2. So this should return 2 because if you divide 13 by 5, the remainder is 2. So the k variable is set to the... Oh no! I got it wrong. 2 times 5 plus 3 equals 13. So the k variable is set to the value of 3. So okay. So let's see. 13 divided by 5. So it's minus 5 minus 5 minus 5 minus 5 minus 5, and we're supposed to come out with 3. So the k variable is set to the value of 3 because 2 times 5 plus 3, so 10 plus 3 equals 13. Okay, Alardians, hello, nice to see you here. And once you learn C, you'll never be free. You'll never be free. Is that a good thing or a bad thing? You cannot compute the remainder with the right argument equal to 0. We hope you can guess why. With the right argument, well, we can't divide by 0. I think that's the reason we're supposed to pick up on. Okay, and we'll move on. So priorities. So far we've treated each operator as if it had no connection to the others. Obviously, such an ideal and simple situation is a rarity in real programming. Also, we very often find that more than one operator in one expression, and then our presumption is no longer so obvious. Consider the following expression. So 2 plus 3 times 5. So, I mean, this is where they teach us the priority of the order of operations. So math order of operations. So I was always taught PEMDAS. So it is parentheses per this is probably not how you spell parentheses. Parentheses and then exponentiation, exponents, and then multiplication, division, addition, and subtraction. Parenthesis, parenthesis, parenthesis. Okay, so parentheses, exponents, multiplication, division, addition, and subtraction. So you do it in this order. So if your memory hasn't followed you, you should know from school that multiplication precedes addition, so you surely remember that you should multiply 3 by 5, and keeping the 15 in your memory, add it to 2, thus getting the result of 17. The phenomenon that causes some operators to act before others is known as the hierarchy of priorities. So the C language precisely defines the priorities of all operators and assumes that operators of a larger or higher priority perform their operations before the operators with the lower priority. So if we know that multiplication has a higher priority than addition, the computation of the final result is pretty obvious. Okay, and Matthew Sundquist, hello, nice to see you here. Hope you're having a good day. Okay, bindings. The binding of an operator determines the order of the computations performed by some operators with equal priority, put side by side in one expression. most operators in the C language have the left-sided binding, which means that the calculations of the expression shown here are conducted from left to right. That is, 3 will be added to 5, and 5 will be added to the result. Okay, so we go left to right when all of the operators are on the same level. So 2 plus 3, so that's 5, and then 5 is going to be added to 5. Okay, so you're probably snorting at this point and saying that all children know perfectly well that addition is commutative, and the order in which the additions are performed has no meaning. Yes, you are right, but not quite. Addition performed by computers are not always commutative. Really, we'll show you this from on later, be patient, okay? SIS for single and SES for plural. Oh, okay. Parentheses. Parentheses, if there's just one, it's parenthesis with an I, and if it's multiple, it's ES, E, parentheses. Okay, moving on. So list of priorities. Since you're new to C language operators, it's not a good idea to show you the complete list of the operators' priorities right now. Instead, we'll show you a truncated version and expand it consistently when we introduce new operators. The table now looks like this. So the unary operators, plus and minus, which makes something positive or negative. And then we've got, on the next level, we've got multiplication, division, and the modulo operation. And then at the bottom of the list is addition and subtraction. And thank you very much, CyberSky, for super chatting. I'm not too sure what currency that is, but it's 40 of it. Thank you very much, CyberSky. Sweet candy from my side, it's my birthday. Happy birthday, CyberSky. And thank you for being in chat. Okay, so note we list the operators in order from the highest to lowest priority. So the highest priority is making something negative or positive, and then multiplication, division, and modulo, and at the bottom, addition and subtraction. So we want to check if you've understood the concept of binding successfully. Try to work through the following expression. So if we're working by PEMDAS over here, it's multiplication before division. So we have to multiply before we divide. So 2 times 3, so that's 6 modulo 5. So 6 modulo 5 is 6 modulo 5 is 6 modulo 5 is sorry. So the modulo operate I'm trying to understand. So 6 modulo 5, that's 6 divided by 5, and then return the remainder. Okay, so this symbol represents the Indian rupee. Oh, okay. Awesome. Thank you. Thank you, CyberSky, for the 40 Indian rupees. Thank you. So let's see. SysOS says 5 divided by 5 equals 1. 5 plus 1 equals 6. So let's see. Return the remainder. So it's going to be return the remainder. So I guess this is going to give us 1. So the 6 modulo 5 equals 1. Okay, both operators multiply and modulo as the same priority, so the result could be guessed only if you know the binding direction. So do you know the result? Check to see if you were right. So the check is 1. So the result is 1, congratulations. Why did they say congratulations like they knew that we were going to get it correct? Parentheses. Of course, we're always allowed to use parentheses, which can change the natural order of calculation. Just like with arithmetic rules, sub-expressions in parentheses are always calculated first. You can use as many parentheses as you need, and we often use them to improve the readability of an expression, even if they don't change the order of operations. So an example expression involving multiple parentheses is given below. Try to compute the value given to the L variable. Okay, so let's go ahead and do this in our terminal over here. So it's like 60 divided by 60 modulo 5 is 0. And precedence order, we're talking about computers, they have no natural order. So 60 modulo 5 is 0, and 64 modulo 5 is 4. So after it is cleanly divided, whatever remains is what we give, right? So it's something like this. So they want us to give the result of L. So let's see, 100, 25, 13. I mean, we can substitute these in. So J is 25, and K is 13, and I is 100, and then K is 13 again. Okay, so I guess what we need to do is we need to do everything inside of the parentheses first. So if there's parentheses inside the parentheses, we need to do that first. So I guess, so 25 modulo 13. 25 modulo 13, so 13 times 2 is 26. So 26 minus 25 gives a remainder of 1. Is that correct? 25 divided by 13, and then take the remainder. So 13, so we subtract 13, and then it's 22, 12. And then we subtract 13 again, and then we need 1 to make it an even number again. No, you only have 25, not 26. We only have 25, not 26. Okay, so subtract once, and it becomes 12. So that's, okay, so this is 12 because it can no longer evenly multiply, right? It's not divide, it's modulo. So that's modulo. So I'm thinking of it as, so if we're dividing this, we first subtract 13 from 25 to get 12, and we can't subtract 13 again, so this is the remainder, right? I think if you use pen and paper, you'd be better in math. Maybe. I mean, I can't show everybody the pen and paper, though, so this is why I use the terminal. Anyway, so, okay, so this is 12 then. So 25 modulo 13 is 12. So 12 plus 100 is 112. And then we've got 2 times 13, which is 26. And so this is all inside of one big parentheses here. So we have 5. So inside of the parentheses, we've got 5, we've got 112, and we've got 26. So this is multiplication goes before division. So it'd be 5 times 112. 5 times 112. Okay, so it's so 5 times 100 is 500. And then we add 5 times 12, which is 50, and then 60. So this is 560. So this would become 560 divided by 26. 560 divided by 26, I'm not sure if I can do that offhand. Cybersky says when modulus comes into negative numbers, that's going to be a nightmare. It's going to be a nightmare. Okay, technically, multiplication and division are in the same level, so you do them left to right. I mean, yeah, we're also doing them left to right here, so 560 divided by 26. Let's just do a quick calculator. $560 divided by 26. This is 21. Did I get my math wrong? Because I expected a an integer number. Brother's computer uses the heaviest calculator he has access to. Okay, so what was the equation again? I mean, we can do this calculation with our with our calculator. I mean, we're just trying to do it manually. Okay, C. Ziegler. Hello, nice to see you here. I want to be your new study buddy. Hello. A browser and Google. Yeah. Okay, so I mean, if we're going by what the 21 point, this big number, that can't be right. I must have screwed up somewhere. Okay, let's try again. Okay, so J is 25, K is 13, I is 100, K is 13 again. So we calculated 25 modulo 13 to be 12. And then we added it to 100 because we have to calculate everything in the parentheses first. So this should be 112. And then this one is 2 times 13, which is 26. So this is the greater parentheses. Oh, you know what? I think... Am I doing the operations in the wrong order? So we got 26. We got 112. Well, I mean, I think we can remove the parentheses at this point. Okay, should be 560 divided by 26. Okay, so it should be this first. We should multiply this first to get 560 and then divide by 26, which is an even operation, which doesn't... Okay, so I think I understand. So this multiplication happens first. So 560 divided by 26. But that's not even, is it? Wait, because we did the 560. And this looks weird. Huh. Okay, let's do this in Python. So if we were to just, you know, put this into like a Python shell. Nano calc.py. Shouldn't be this hard. Print L. Oh, it is supposed to be a floating point number. Yeah, no, I just kind of assumed. Your remainder of 14. Let's go back. Where are we? You're trying to use floating point maths for integer math. Floating point math for integer math. Let's just take a look at what the answer is supposed to be. So I mean, when we ran it from the terminal here, oh, wrong terminal. We got 10.76 something something. Let's see what the answer is supposed to be. 10. Okay, so it's supposed to be 10, but how do we? You got 10. Okay, okay. Just do it directly in Python. When we did it in Python, Python gave us 10.7. Oh, although I guess because we're doing integer calculation, we just drop everything after the point. Okay, there's a remainder there which is not used. I did it in idle. Okay, okay. So it says 10, sure, and I guess because everything is an integer, the division is also integer division, which drops everything. Okay, and I guess we'll move on. Postfix and prefix operations. Okay, so we got some sheep. There's some operators in the C language which you won't find in the mathematics textbooks. Some of them are frequently used when you want to increment a variable by 1. We often do this when something is counted. For example, sheep, let's consider the following snippet. Integer sheep counter equals 0. Every time a sheep runs through our thoughts when we want the variable to be incremented, we do this. So sheep counter equals sheep counter plus 1. Similar operations appear very frequently in typical programs, so the creators of the C language introduced a set of special operators for them. One is the plus plus operator, which increases something by 1. You can achieve the same effect in a shorter way. So it's sheep counter plus plus. Okay, not drop. Rounding, not drop, it's not part of the calculation. Thinking drops would bite you later. Okay, it looks much more elegant, doesn't it? So sheep counter plus plus instead of sheep counter equals sheep counter plus 1. Similarly, you can decrease the value of a chosen variable. If we can't wait for the holidays, our mind does the following operation every morning. Days until holiday equals days until holiday minus 1. But you can also write it as days until holiday minus minus. What is fun, you can also do the plus plus at the beginning of the variable. You can do plus plus days until, well, I've never seen it like that. Okay, so we have to introduce some new words. So plus plus operator is called the increment operator, and minus minus operator is called the decrement operator. Okay, so we've shown you plus plus and minus minus operators after a variable. A specialist in the syntax programming languages would say that they're used as postfix operators. However, both operators can be placed in front of a variable as well as prefix operators like this. So plus plus sheep counter or minus minus days until holiday. So I mean, this is these are the same, right? If you put it at the beginning or if you put it at the end, it's kind of the same thing, right? Or are they different? They do work slightly differently. That's not what I wanted to hear. The effect will be exactly the same. Sheep counter will be increased by 1. Days until holiday is decremented by 1. There's a fairly significant difference, however, which is described by the precise names of these operators. Okay, I guess they'll talk about it in the next section. Postfix and prefix incrementation decrementation. The following two operations may seem a little weird to you, but it'll all take a short time to understand. Let's discuss the effects of the operators. Operation, plus plus variable, minus minus variable. So increment or decrement the variable by 1 and return its value already increased or reduced. Operation variable plus plus or variable minus minus. return the original unchanged variable's value, then increment or decrement the variable by 1. Okay, so subtract first and then return the value. And then this one is return the value and then subtract or add. This behavior justifies the presence of the prefixed pre before and the post after in the operator's names. Pre because the variable is modified first, and then its value is used. Post because the variable's value is used and then modified. Okay, Second the Mind says, got it. So the order in the ASM compiles differently. The order, yeah, I guess the assembly instructions, they must come in a different order in this case, right? Okay, prefix and postfix operators and their priorities. Let's take a look at two simple examples. Integers I and j. I equals 1. J equals I plus plus. So j equals I, and then add 1. So first the variable I is set to 1. In the second statement, we see the following steps. The value of I will be taken as we use the post incrementation. The variable of I will be increased by 1. Okay, in effect, j will receive the value of 1, and I the value of 2. Wait, j equals I, and then j equals I before it's incremented, and I will be incremented by 1 and will become 2. If you hate your life, then start learning assembly. I mean, assembly is its own kettle of fish. I started learning some stuff about assembly, not very detailed stuff, just enough to start doing a little bit of binary exploitation, reverse engineering. Okay, things go a bit differently here. So I and j, I equals 1, j plus plus equals plus plus I. So j is 2. J is 2, and I is also 2? Oh, interesting. So I and j are the same in this circumstance because the incrementation happens before the value of I is returned. But in this case, j equals 1, but I is incremented to 2, which seems kind of weird. Okay, look carefully at this program. Let's trace its execution step by step. So integers I, j, I equals 4, j equals 2 times I plus plus, so I incremented. I equals 2 times decrement j. Okay, let's before we take a look at the explanation here, let's think about what this could be, right? So I equals 4, j equals 2 times I. So 2 times I. So 2 times I is 8. So j equals 8. But I becomes incremented. So I becomes 5. So j becomes 8, and I becomes 5. And then I is 2 times decrement j. So j is currently 8, so j becomes 7. J becomes 7, and then multiplied by 2. So 7 times 2 is 14, so I equals 14. Let's see if I've got that correct. So I, the variable, is assigned the value of 4. We take its original value of I, 4, and then multiply it by 2, and assign the result 8 to j. and eventually post increment the I variable so it equals 5 now. We pre-decrement the value of j, it equals 7 now, and then reduce the value taken and multiplied by 2, and the result 14 is assigned to the variable I. So I think we got it correct in this case. Okay, so what else do you need to know about the new operators? Firstly, the priority is quite high. Higher than the multiplication, division, and modulo operators. Secondly, their binding depends on whether you use the prefix or postfix version. The prefix version operators have a right to left binding, whereas the postfix operators bind from left to right. The prefix version operators have a right to left binding. Okay, so our priority table now reads as follows. So increment, decrement, and then positive and negative. And then multiplication, division, and modulo, and then addition and subtraction, and then equals. Shortcut operators. So it's time for the next set of assignment operators to make a developer's life easier. Those described earlier deal with addition and subtraction of 1. Very often we need something other than addition or subtraction, or we want to use a value other than 1. Consider the expression below. So I equals I times 2. So we can use it when calculating a series of powers of 2. Here's another example. We could use this expression. Sheep counter equals sheep counter plus 10. In the C language, there's a shortened way to write these operations. Okay, the last equals is assign. Equals would be equals equals. So yeah, you're right. I mean, I guess we could use, yeah, it's an assignment operator, right? In the C language, there's a shortened way to write these operations. I times equals 2. Times equals, I mean, I'm not too sure what the, I is multiplied and equal to 2. Sheep counter plus equals 10. So we take the value of I and then multiply it by 2. We take the sheep counter variable and then we add to it 10. So I times equals 2 means I equals I times 2. Yeah, I think so. Let's try to present a general description for such operations if OP is a 2-argument operator. This is very important condition, and the operator is used in the following context. Variable equals variable OP expression. Then this expression can be simplified as follows. Variable OP equals expression. Variable operator equals expression. So we've got, ooh, this is really big. Let's make it a bit smaller. So I equals I plus 2 times j. We can express that as I plus equals 2 times j. Okay, and then we got variable equals variable divided by 2. And we've got variable divided equal 2. Rem equals rem modulo 10, or rem modulo equals 10. J equals j minus I plus var plus rem, or j minus equals I plus var plus rem. Okay. I think we should be able to follow along with this. Okay, so let's see. We've got more coding exercises here. So fixing errors done in program, doing simple math with operators, variables, and numbers, printing on screen. Okay, let's see. Fix all the errors. The expected output is the value of half is 0.5, and the value of pi is 3.141593. Okay, Anna Kit, hello, nice to see you here. Which site is best to learn Python from 0 to advanced? This is a pretty good website here. Sign up for the website. They've got a Essentials of Python. They've got 2 Essentials of Python courses, and I think the same link can be found over at our education links, at our education resources for programming. Over here. Give this a look. So we got links for Python Institute, Python Essentials 1 and 2. So together, they're a 70-hour course, and you should be able to learn your basics of Python after 70 hours of learning. Okay, so let's see if we've got some errors in here. So int main includes standard.io.h, and I think this is fine. Float half value, float pi value. Ah, we've got an extra plus in here. Let's get rid of that. Float pi value equals 0.141592565 minus 3. Minus 3. So this is supposed to be plus 3, isn't it? Cyrus Guy says, I like W3 schools. I mean, I like W3 schools as well, but W3 schools doesn't... It's a bit more... It's a bit less of a complete course, but it's very good for individual lessons. Okay, and let's see. The value of half is 0.5 and then 5 zeros. I am the light pole. Hello, nice to see you here. What is up? So 0.6 plus 0.1. I mean, we want this to be minus. So how many decimal points are here? It's 1, 2, 3, 4, 5, 6, 7. So there's 8 decimal points here. I'm pretty sure this isn't going to go. If we just run this, oh, it did give us the correct number for pi. Study bloggers, hello, nice to see you here. Hope you're having a good day. Okay, so we've got the correct output for both of these numbers. We can move on. Okay, check the program in the editor, find all the possible compilation errors and logic errors. Sure. So the value of 4 is 4, and the value of 5 is 5. This is what we expect. So 4 value equals, I mean, 2 plus 2. And 5 value is 2 plus 3. Okay, good day, how about you? I'm just here doing a study session. So I'm studying, other people can watch, other people can ask questions. Just trying to get some studying done and hanging out with the chat. So the value of 4 is, the value of 5 is, so we're dealing with whole numbers, so %d, 4 value and 5 value. I think this should be fine. Let's run the code. The value of 4 is 4, the value of 5 is 5. Good, great. Python? No, this is C. This is C language. So I'm trying to teach myself C because C is an important language for reverse engineering as well as binary exploitation, and that's why I want to learn it. Okay, it's a normal shy stream without the gaming. I mean, there's only really one topic that we're doing today, and we're just kind of like slowly working through it. So let's see. We want the value of 10 is 10, and the value of 12 is 12. So we've got 6 decimal points after each one of these. Blogger says C is pretty good, but it's kind of tough. It's kind of tough. I mean, we're also learning math because apparently I'm not very good at math. No, I never claimed to be good at math. Anyways, so we got floating point numbers. Floating point numbers 10 value, and 12 value. This looks okay. We've got all of our stuff. So 10 value is 2 and 3 and 4. 2 and 3 and 4, how does this make 10? So this would be 2 times 3 plus 4. So that makes 10. So this is 6 plus 4 is 10. And then we've got 12 value is... How do we make 12 with these numbers? After microcode, C is easy. So 3.5, 2.5. We're trying to make the number 12. So this is... maybe 2 times 2.5. So that's going to be 5. And then plus 2 times 3.5. So 3.5 times 2 is 7. 7 plus 5. 7 plus 5 is 12. Yeah, I mean, that should go through. Let's run the code. The value of 10 is 10. The value of 12 is 12. All right, great. Let's move on. And then the value of 10 is 10. The value of 20 is 20. So we're dealing with integers in this case. We need to make sure that we're printing out integers. Let's see. So 10 value, 20 value. I don't see any problems with the print statements. Okay, so let's fix up the 10 value first. So this is 3 something modulo 14. We need to modulo by 14 in order to get 10. So this must be multiply, right? So 3 times 8. So 3 times 8 is 24. 24 modulo 14. 24 modulo 14 is 10. Or at least I think it is. I guess we'll figure it out in just a second. So int 20 value equals 2. 2 times 10 value. 2 times 10 value. What is happening here? Okay, Nelson Ray, hello, nice to see you here. What is up? Welcome to the stream. Let's see, 20 value equals 2 times 10 value, and then what do we do here? So there's a 10 and a 5. Do we want to multiply by 10? Divide by 10? Two times 10 value. Okay, fix them, but do not change any of the numeric values. So we can't change these numeric values when we're editing the code. So what is this puzzle we're doing? So 20 value equals 2. Are we supposed to put in like division or... Because 10 value is 10. So 10 times 10 Maybe 10 divided by 10? No. 10 divided by 10 is 1. 1 times 5. 1 times 5 divided by 1 times 5 times 2. So if we do it like this, then it works. So 10 value, so 10 divided by 10 is 1. So 1 times 5 is 5, and 2 times 5 is 10. No. Wait, that's 10. This should come out as 20. What am I doing wrong here? We want the final... So whatever is multiplied by 2 has to be 2 times 10. So how do we get this portion to come out to 10 with these numbers? So 10 times 10, 100. So 10 times 10 is 100. And then we could divide by 5. 100 divided by 5 is 20. No, that doesn't work. Reverse the operations and see the answer. Reverse the operations and see the answer. I mean, we can... Let's take a look at this. Do a little... Where is my editing window? Here it is. Okay, so x times 10 divided by 5. Apparently we're learning math, huh? Okay. So 10 value is 10. So I guess x and then 10 and then 5 and then 2. So we need to put some operators between these values in order to get the value 20. So I guess we could call this 20 equals 2 and then something with x and then something with 5. Hint is try increment. Increment? Okay. Try addition? Is this what you're trying to say, CyberSky? So 10, something with 10. So we could do maybe something like this. Addition, okay, addition. So 2, and then something with 10, and then something with 15. Can we do something? Ten modulo 5 is 0. He poussage. Hello, nice to see you here. 10 modulo 5 is 0. 10 modulo 5. So plus 10 modulo 5 plus 0. So 2 times 10 plus 10 modulo 5, which is 0. So 2 times 10 plus 0. Yeah, I mean, that could work. Thanks for the hint, Hipusage. So this is modulo 5. And then it's 10 value times 2. Plus 10 modulo 5. I mean, I guess we don't need the, we don't need the parentheses here. Okay, in this site, you tell me Python scripting also includes Python scripting. I mean, we're not really Python scripting right now. This is C code. I mean, I use Python every once in a while to do some calculations. But this is C. So 20 value equals 2 times 10 value plus 10 modulo 5. So 2 times 10 plus 0. Okay, we'll try running this. The value of 10 is 10, the value of 20 is 20. Okay, awesome. Move on to the next thing. Okay, let's see. Fix the compilation errors and logic errors, but do not change the numeric values. So we can't touch the numeric values. And I'm also guessing that we can't touch the... well, maybe we can change the operators. Okay, so the expected value is the value of 8 is 8 with 8 value. Yeah, finally. Yeah. Okay, so x value equals... Oh. X value equals 2 times 6 modulo 5. So multiplication and modulo have the same priority, so it's 2 times 6. So sorry, 4 times 6, so this is 24. 24 modulo 5. 24 modulo 5 is... This is 4. Sorry. So this, the result of this should be 4. So the x value is 4. And then 8 value is 2 something x value 10 and 5. Okay. Oh, it's not hash, right? Okay, so it's // for comments. Right, Cybersky, you're right. Hash is for comments in Python. So 8 value equals 2 x value. Well, let's take a look at it over here. So in this case, x value is 4. So if x value is 4, then we need to figure out how to get 8 out of these 4 numbers. So it's not 8 value in this case, it's just 8. I mean, we could also do like the modulo trick again. So 10 modulo 5 is 0, and then it's 2 times 4 plus 10 modulo 5, and this gives us some. This gives us 8, or it should. I mean, if we run it through in Python, you could do the same as before, but you could do and instead of modulo, comparing the least significant byte. I mean, they haven't taught us that operator yet. Do you mean addition instead of modulo, or something else? So if we run this through Python, so Python print Python C print this stuff, then we get 8. I'm finding loopholes with the modulo operator. I mean, these are the operators that are given to us. What else could it be in this case? So we've got a 2, a 4, a 10, and a 5, and we need to get 8. How else could we do it? I mean, if you guys want to give suggestions, I'm happy to hear it. Because no worries about your grammar. It's fine. So 2. I'm not a math person. So if we're just using regular math operators, we've got our addition, subtraction, multiplication, division, and we got the modulo. I'm not too sure how else we can arrive at 8. Maybe 10 is divided by 5. So 10 divided by 5 is 2. 2 times... Two times something? No, I think it was okay with the modulo operator. Yeah. Anyways, let's just move. We'll move on to the next thing. I'm not really here to learn about math. I'm more here to learn about the C programming language. Okay, so we've got same thing. Do they have to be in that order? Hello, Cypher. Nice to see you here. They do have to be in, the numbers do have to be in this order, but we can put different operations between them. If you guys want to try it out yourself, yeah, focus on the C. 8 equals 2, 4, 10, and 5, and then you have to do some operations between these. Okay, so we want you to act as intelligently or naturally compiler and translate the formula into real C code notation. Test your code using the data we've provided. Result equals 38, and big result equals this other number. Okay, so we've got result and big result. These are both integer numbers. Okay, they want us to... Oh, man. Well, let's take a look at these. You're up late? Daypril, hello, nice to see you here. I missed C. You didn't miss C, we're in the middle of C right now. I'm up late? Yeah, I need to teach myself C, and I might as well do it on stream to make it a little bit more entertaining for everybody. Well, entertaining for everybody who wants to see me struggle with math. Okay, so they say what we need to do. So x value and y value. X value equals 5, y value equals 9. And we've got a result and a big result. So they want us to do increment x value by 3. So x value plus equals 3, like this. And then decrement y value by x value. So this would be y value minus equals x value. Okay, the next thing they want us to do is multiply x value times y value giving result. So result equals x value times y value. And the next instruction is increment result by result. Result plus plus. So of course, because this is C, all of these statements have to have a semicolon at the end of them. So increment result by result, decrement result by 1. Increment result, oh sorry, increment result by result is not this. It's increment result plus equals result, like this. Okay, Cypher says it's July. I can't believe we can say Happy Christmas now. Happy Christmas? Happy Christmas in July? Maybe July 25th, I'm not sure. Well, in C, the space, enter, and tab have no real meaning between statements. I mean, when we copy-paste this stuff into the coding window, we might have to change the formatting a little bit. Okay, so result plus equals result, and then decrement result by 1. So result minus minus. Assign result modulo result to... Wait, assign result modulo result to y value. Okay, so that means y value equals result modulo result. Wait, any number modulo with itself is going to be 0. Result y value equals result modulo result. So this is, so y value equals 0, right? Unless I've got something really wrong. Okay, and then increment result by result added to x value. Cybersky says, my favorite movie, Werewolf. There's a werewolf movie coming out? Increment result by result added to x value. Increment result by result added to x value. So result plus equals result plus x value. Okay, and the next one is assign result times result to big result. So big, oh, I forgot to put into my semicolons. Big result equals result times result times result. What are we doing here? Okay, and the last one is increment result by x value times y value. So result plus equals x value times y value. Big result is an awesome variable name. I didn't name it. Okay, so these are the 1, 2, 3, 4, 5, 6, 7, 8, 9 operations, or the 9 lines of code. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see if this works. It implies a tiny result. Big result is an awesome variable name. It implies a tiny result. I mean, if we're going by opposites, then maybe yeah. Okay, the problem is that the manipulations have been described using natural language, so the code is completely useless now. All right, let's paste in our code. I hope this works. So it says A modulo A is a common operator to clear A in assembly, or using something for doing it bitwise. So that would be, what is it called? XOR, right? XOR with itself. XOR something XOR results in zeros. Okay, let's run the code. Result equals 38. Big result equals 5. Oh, what is this? 54,872. 54,872. So pipe are bitwise operators in C2? Oh, I'm not sure. I'm not sure. I haven't gotten to that point yet. Okay, let's, well, we got the correct results. Let's continue. Okay, so check the program in the editor. Find all possible compilation errors and logic errors. However, you may use parentheses. You can add or remove them. Your version of the program must print the same results as the expected output. Before you use something, try to find the errors only by manual code analysis. So the expected output is the result is 28 and the big result is 59. Okay, so what's going on here? X triple, hello, nice to see you here. Python or C++ to start learning? It really depends on what you want to, where you want to be at the end of your journey, X triple. If you're going specifically into reverse engineering or binary exploitation, then C++ might be the better way to do it. But Python is also very valuable in those fields as well. XACGG, hello, nice to see you here. Wild Radio Root, hello, nice to see you here. Thank you for coming by the stream. But XAAA, I'd say that Python is a pretty good place to start. After you learn Python, C becomes easier. But you could also start with C and then, or C++ and then move on to Python. There's a lot of it's not that there are a lot of similarities between the two, but if you learn the syntax of one, the syntax of the other one becomes a lot easier to pick up on. Okay, so 5 and 9. Result equals 28. So result equals 28. X value, Y value, and then 2. X value and then Y value, and then I guess we need to put this between the parentheses. So X value, Y value equals 14. 14 times 2 is 28. That makes sense. Yeah, I mean, for ease of learning, Python is a lot easier to learn than C. And Python will also benefit you in a bunch of other areas as well. I'd say that Python is a lot easier to use if you move around to different areas in tech. You learning C programming? Stop kidding us. Stop kidding us? Well, I mean, I'm trying to learn. I'm trying to learn another language. So what is this? Big result is X value and then Y value and 6. So, I mean, if we take Y value, so 9 times 6. 9 times 6 is 54? 54 plus 5 is not the value we're looking for. We're looking for something that results in 59. You can type your Python, it's kind of a step towards C. Okay, SysOS says, but both can be messy if you lack pure programming skills. SysOS says, Python lets you make more of a mess than C allows. That's true, because Python is a dynamically typed programming language, and C is statically typed. So we need 5 and 9 and 6, and we need to arrive at 59. So maybe... where can we put our parentheses? So 5 times 9 is... 5 times 9 is... 45. 45 times 6 is way too much. What is the value? 9 times 6 is 54, and then we add 5. Oh, no, no, that's it. That's it. Okay, so we need to put our parentheses here. So y value is 9 times 6, 54, plus 5 is 59. So we run this, and then we get the correct result. Okay, April says you can type your Python, but it's kind of a step towards C. Yeah. Okay, we'll move on to the next thing. Okay, so what are we doing here? You can use parentheses. Your version of the program must print the same result. So the result is 20. The small result is 5. Okay, and then we've got... Let's check these printf statements. Small result and result. Okay. Progressing in his math. Well, you know, I'm trying to improve. I mean, there's also a reason why I use a computer, because the computer can do the math. But I guess understanding how the math works is also a good thing. So result equals... So x value, so it's 3 and 2. Times 2 plus y value. So y value is 2. 2 plus 2. 2 plus 2 is 4. Oh, it's 4 times 5. So this is, if we put the parentheses here and here, then we get 4 times 5, which is 20. I told you it was a tiny result. Okay, small result is 5. So small result is x value plus y value times 4 minus y value. So we want to get... So I guess what we want to do for the small result is we want to... We want to multiply by a negative number, maybe? How can we achieve that? Four minus x value is 2. So times 2, but we want to get a small result that is smaller. We can't change the values of x. So maybe... You can use parentheses, you can add or remove them. Your version of the program must print the same result as the expected output. We can't change any numerical values. So x value plus y value is 5. 5 times 4. Yeah, how do we put in our parentheses to make sure we get a small result like 5? Maybe like, well, that doesn't really work. PEDMAS. Yeah, we're dealing with parentheses, exponents, multiplication, division, addition, and subtraction. But, I mean, they tell us that the only thing we can do is we can put in parentheses. Try writing it in nano. Okay, so... Let's copy this. Okay, so we're trying to calculate small result. So a small result is 5. 5 equals x value plus y value times 4 times minus x value. So x value will plug in the values. So this is 3, x value is 3, and then y value is 2. I think there are no parentheses needed. Oh, times 1. Oh, it is times 1. Jeez. Okay. So let's see. It is close to 10 o'clock right now. We might be able to do another hour. It still leaves me with enough time to go to bed at a reasonable hour if I do another hour of this. Okay. So yeah, we don't need to do any parentheses here. No, we do need to put parentheses for 4 minus 3, like this. Otherwise it doesn't work. So this would be 4 minus 3, which is 1 times 2. 1 times 2 plus 3. 1 times 2 plus 3 is 5. Why don't we use Vim? That's a good question. I teach people how to use Nano. I never really taught myself how to use Vim. I know that there's a lot of powerful tools. There's a lot of powerful functions you can do in Vim, but I use Nano for the simplicity. Anyways, okay, so we just need to put the parentheses around the last two, and it should be fine. Yeah, okay. And run the code. The result is 20, the small result is 5. Done. Great. Next. Okay, so let's do order of operations. Use the parentheses to change the order of operations printing on screen. Let's see. Fix them, don't change any of the numeric values. You can use parentheses. Your version of the program must print the same result. Before you use the compiler, try to find the errors only by manual code analysis. The result is 4, the small result is 7. Okay, so there's nothing wrong with the print statements. No, there is something wrong with the print statement. We need to remove this space. Okay, but aside from that, everything's fine. We need to print the result as 4. So result equals x value modulo y value times 14 modulo y value. So we need to get the number 4. Let's try this out in Nano. So result equals 4, and small result equals 7. Okay, Cybers guys, if you have normal game mode, no more Nano, why don't you try hardcore mode Vim? I mean, I might teach myself Nano in the future, maybe as like a sub goal or something, or you know, if somebody donates a bunch of money and says learn Vim, and I might say yes. Who knows? Where does modulo fit into the order of operations? So if we're talking about the order of operations, modulo is a higher order of operation. So it's multiplication, division, and modulo are all on the same level. If they compete against each other, it's from left to right. Okay, why not skip the nonsense and go to micro? I don't know. Good question. Okay, and then plus and minus are below those in the tier list. Okay, so 4 equals so we've got 4 modulo, sorry, x value, y value. So x value is 5, 5 modulo 4 times 14 modulo y value, which is 3. So let's calculate this first. So how can we get a result of 4 with these numbers? We can put some parentheses in between them. So it's something times something. So if it's 14 modulo 3, this results in 1. So it's 3 times 4 is 12. 3 times 4 is 12, leaving 2. So something times 2. So if it's like 2 times 2, then it's fine. But I don't think this is 1. So 5 modulo 4. 5 modulo 4 is 1. So 1 times 2 is not 4. I mean, we could put the parentheses here, maybe? So 4 times 14. Four times 14 is, let's see, 28 plus 28. 28 plus 28 is 56. So 56 modulo 3. This would become what? 5 modulo 56 modulo 3. No, 3. And if that's the case, this would be 5 modulo 56. So 5 divided by 56. 5 divided by 56 is... But this would never... Moduloing anything by 3 will never result in the number 4. So this can't be the answer. If we just do this straight, 5 modulo 4 is 1. And then so 1... We can never modulo by 3 straight up to get a result of 4. Okay, Grey Wolf Medi says, when I was 13, I was in IRC, a script kiddie at the time. Someone took over my screen, talked for a while, and then he suggested C was the next big thing, and had me learn that. Grey Wolf Medi, hello, nice to see you here. Did you learn C? And has C come in handy for you? Let us know. So this can't be... So we need to take this result first, I think. So 14 modulo 3, that is, that's 2, right? So it has to be something times 2. So something times 2, 4 equals... Maybe 4 times 2? 4 times 2, 8 modulo 5? But 8 modulo 5 is not 4. Exact says, well, C is still the big thing. I mean, there's still a lot of C being used, yeah. Video title, Learning Math with Use of C Coding. Learning Math with the use of C Coding, of course. So 4 times 2. Eight. So that's 8 times 8 modulo 5 modulo 4 is 1. We can't do 1 times. We can't do 1 times 2. It has to be 4 times 2, 8, and 5 modulo 8. But this doesn't result in 4 either. Or maybe, do I have the numbers wrong? So result equals 14. So the 14 is the big factor here, I guess. Y value is 3. So anything... We can't leave the modulo for last, because anything modulo with 3, the result has to be less than 3. And we want result to equal 4. X value is 5, 5. Five modulo y value 3 times 14. 3 times 14 is 30, 42. This is 42. So it would be 5 modulo 42. So 5 modulo 42 is basically the same as 5 minus 42. And 5 minus 42 is 37. So if it's 37, modulo 3. Yeah, that's not going to work. Okay, let's see. SysOS says, C is the glue language of choice. All interactions between languages work based on C specs. I mean, if you learn C, you can understand a lot of other programming languages that are based on C as well, and there are quite a few of them. Okay, let's go back to the drawing board. So we're trying to calculate result first. Result is 4. So 4 equals x value modulo y value. X value 5, 5 modulo y value 3 times 14 modulo y value, which is 3. So what can we do with these numbers to result in the number 4? 14 modulo 3 is 2. 2 times 2 would give us 4. 5 modulo 3 Wait, this is... So we just... Basically, we have to do this, right? We need to put our parentheses here to result in 2 times 2, which gets us 4 for the regular result. So then we just need to calculate the small result. Okay, so small result is 7. So we need to calculate that. So 7 is x value plus 10 modulo 4 modulo x value. So we're only dealing with x value, which is 5. 5 plus 10 modulo 4 modulo 5. That has an extra opening parentheses. Oh, really? Well, I mean, this parentheses right here, it's indicating to us that we can add our parentheses. We could put the other parentheses somewhere else, or we can remove the parentheses. Because in the exercise, it says that you can use parentheses, you can add or remove them. And we need to find something that results in the number 7. 7 modulo... So 5 plus 10 isn't going to work. So we can't do it this way. It has to be 5 plus 2. So whatever's on this side has to result in 2, because we need to add 5. So 5 plus 2 on this side. You have an open one that isn't closed. You mean up here? Oh yeah, you're right. So we just need to remove this. Thanks for letting me know about that. Okay, so we need to find a way for this part of the thing to equal 2. Experiment! Hello, nice to see you here. What is up? So 10 modulo 4. 10 modulo 4 is 2. 2 modulo 5 is 3. 10 modulo 4 is... 10 modulo 4 is 2. So this is 2. 2 modulo 5 is the same as 5 minus 2, which is 3. So this is not the way it's supposed to go. We do 4 modulo 5, which is the same as 5 minus 4, which is 1. And then 10 modulo 1. 10 modulo 1 is... 10 modulo 1? 10 modulo 1 is 1. No, 10 modulo 1 is 0. Because it divides evenly. So this would result in 0. So 5 plus 0, that doesn't work. We could also do it... Yeah, 10 modulo 1 is 0. Yeah, it divides evenly. So this is... we can't do it this way. We have to do it 10 modulo 4. 10 modulo 4 is 2. 2 modulo 5 is 3. That doesn't work. We can also do... so yeah, it doesn't work either way. Oh, did I get that wrong? 4 modulo 5? 4 modulo 5 is the same as 4 divided by 5? 4 divided by 5 is... 4 divided by 5, take the remainder, is 4. You're correct. You're correct, SOS. So it's 4 So that would be 2. Oh, this would result in 2. So we would have to put the parentheses over here. So 4 modulo 5. I told you guys my math is no good. Okay, x value plus 10. X value 5 plus 10, 15. 15 modulo 2. Wait, what did we calculate it as? 7. So 7 has to be 7 plus 2. 5 plus 2. So 5 plus. Yeah. So we need to put an extra parentheses over here. Okay, and we'll try running the code. The result is 4, the small result is 7. Okay, that was the correct one. Haven't done this stuff in a long time. Yeah, I mean, I'm not... I'm also struggling. Okay, order of operations printing on the screen. Complete the program in the editor, complete the accrued amount of money, starting with the starting value of 100, and an annual interest rate of 1.5. Uh-oh. Need to train some new brain cells to replace the ones that died off. Yeah, I need to... do some more math education. Your version of the program must print the same result as the expected output for each year. Compute each annual value on the basis of the previous year's value. After first year, after second year, after third year. So we've got a bunch of... This is a bit less clean because we're dealing with decimals. So we're talking about floats. First year value, second year value, third year value. Return 0. Okay, complete the program in the editor. Compute the accrued amount of money, starting with the value of 100 and an annual interest rate of 1.5. Compute and print the results for the first 3 years. Okay, so the annual interest rate is 1.5. Annual interest rate equals 1.5. Interest rate equals 0.015. Okay, let's think about this. Okay, SysOS says hint times 1 plus % will yield the base value plus this new percentage. Okay, let's go back in. So my code goes here. So start value is 100. Interest rate equals 0.015. And they tell us that the annual interest rate is 1.5%. The annual interest rate is 1.5%. So float annual interest equals 1.5. Compute and print the results for the first 3 years. So after the first year, it should be 101.5. So first year value, we need to modify these. First year value equals something. Okay, enter straight. @Val says, thanks for the opportunity to learn this forbidden subject. Is it a forbidden subject? I'm just here to to show everybody how I struggle to learn new stuff. And if you learn something out of this, then I'm happy. So first year value equals, well, you multiply it, right? So it's times equals annual interest. So this should result in what we're looking for there. So for the second year value is times equal first year value it's first year value times annual interest. Wait, did I misspell annual interest? No. Wait, is that how you spell annual? Anyways. It's going to be a compiler error? Oh, really? 1.15 or 0.015. 0.015. Oh, okay. So we should be using interest rate instead of defining our own variable here. And first year value has no value. Oh, that's true. We need to incorporate start value. So first year value is start value and then how do we So 1.15% is this thing over here. So how do we multiply by this? So do we just do 1 plus interest rate? 1 plus interest rate times start value? So I can multiply by 1 plus interest rate to multiply by 1.015. 90% of 100 equals 100. What was it? 100 times 0.9 equals 90 something something. I wonder if this works. I mean, I'm not sure if this is the way they want us to do it. But we could just add 1 and then multiply by this, and it should give us the same value. And the second year value would be equal to the first year value times the same thing. So 1 plus interest rate. Okay, try it. Yeah, I mean we can give it a try, and then we got third year value, which is equal to second year value times 1 plus interest rate. Whoops, we need to make sure to spell everything correctly. Otherwise it doesn't go. Okay, so first year value equals start value times 1 plus interest rate. Second year value is first year value times 1 plus interest rate. And third year value equals second year value times 1 plus interest rate. We'll see if this works out. If not, we're going to have to adjust ourselves. So our code goes over here. Okay, and we'll run it. So first year is correct, second year is correct, third year is correct. Wait, third year is different. Why is the third year different? Third year 544,998, but we've got 567,833. So something happened. What went wrong here? So we take the first year, the second year is based on the first year, and then we multiply again. The third year takes the second year, and then we multiply again. Why do we get a different value? Compute each annual value on the basis of the previous year's value. Compute each annual value on the basis of the previous year's value. Must be something to do with the floats. So the floats, they're accurate to 6 decimal places. They're accurate to 6 decimal places here. So we got the same second year value. And we're doing the same thing, we just add 1 plus interest rate as our multiple. Yeah, what's wrong with these? What's wrong with the decimal numbers? I mean, we could also define, I don't know if making this explicitly a float does anything different to this. We'll try running it again. Yeah, we still have the wrong value for the third year. My calculator agrees with the program and not the given input and the given output. The expected output is 1. Yeah, this is not the same number. Must we use doubles or floats? Must we use doubles or floats? Complete the program in the editor. Compute the accrued amount of money starting with the value of 100 and an annual interest rate of 1.5. Compute and print the results for the first 3 years. That must print the same results as the expected output for each year. So, I mean, can we switch these to doubles? If we switch this to a double, I don't know if it's going to change everything a lot. So 1.0 is a double, not a float. 1.0 is a double, not a float. Okay, how can you tell though? Does it default to double? Hold on. Let's try this. So float third year value, and we're gonna add an extra variable. Float 1 1 float equals 1.0. Okay, and we'll just do the interest rate plus 1 float here instead. And see if that does anything different. It defaults to double. I believe you need to use 1F0 for a float, but that's old knowledge, could be outdated. Okay. Well, let's see. Can we reset this, and then we'll run the code. Expected before. Oh, okay. I forgot to put my semicolon here. Nope, still don't have a matching number here. It's funny that it's accurate up until the second year, and then in the third year it deviates. How do we... compute and print the results for the first 3 years? Maybe if we take a different method for calculating the first year, second year, and third year value. We definitely want to multiply the start value by something. Wait, maybe we should increment the... No, incrementing the interest rate will modify its value. We don't want to do that. Okay, so maybe this is a question we want to ask the AI. So we'll copy this. We'll ask the AI this question. Okay, I am coding in C with this program. Or on Google, that will give you the AI anyway. Okay. In our course, the expected result for third year value is this number. But ours does not match. Why? Okay, should I even use Claude? Persona management, more of these C programming streams, please. I'm glad that somebody likes them. I mean, I need to teach myself this anyway, so I might be doing some more streams on off days at the same time. Should I use Claude? I mean, Claude is supposed to be good for... It's supposed to be good for coding. I haven't really used it myself. The code is mathematically fine. The mismatch comes from the floating point precision in C, not from the formula itself. Float has limited precision, so values like this, repeated multiplication, accumulate rounding errors, which is why your printed result may differ slightly from the course's expected result. So in C, float is a single precision type, so decimal values are often stored as the nearest binary approximation instead of the exact value. When you compute compound interest over multiple years, the tiny rounding differences stack up across each multiplication. What the course likely expects. So it expects this one. It's consistent with a particular float rounding path, while your compiler platform may produce a slightly different last digit or two. This can happen even if the formula is identical, because floating point output depends on how the compiler evaluates expressions and how printf rounds the stored value. How to make it more stable. Use double instead of float for the calculations, and print with a suitable precision. For example, double first year value, second year value, third year value. Okay, so they're asking us to convert everything to doubles. Okay, let's see. SysOS says no, don't use Claude. Dapril says, I don't think you can say no unless you are a dev. You'll never be able to compete with the output speed. We didn't see an error with the second year, though. One more detail, if your instructor is comparing each text output, they may be using a specific type, compiler, or rounding rule. In this case, the safest fix is to match their expected type and formatting, not just the formula. Okay, so what happens if we make everything a double instead of a float? So just go back in and set everything as a double. Double, 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 and then last double, and then an extra double. Okay, and we'll try running it again. Actually, let's reset that and then run it. Oh, now we've got two different ones. So the second year and the third year are now wrong. So the second year is wrong, the third year is wrong. And this comes from setting our double. So I wonder what the problem is here. Can we ask questions? Let's see, download, upload, reset, share, tip. Oh, okay, we can get a tip. The sample solution will replace your current work in the editor. Do you want to see it? Show sample solution. Sure, sure. I mean, we've worked on this long enough. Okay, so these are still floats. So start value, let's see. Interest rate, 0.05. And we've got first year value equals start value plus start value. What? Start value plus start value times interest. Start value plus start value times interest rate. So that's 100. Oh, okay, okay. So you're adding the interest to start value. So it does this calculation first, and then it adds it to start value. Okay, dark. Do you want it in dark mode? Okay, let's sure, we can set it to dark mode. Let's see. Dark color. Okay, if it makes you happy. Second year value equals first year value plus first year value times interest. So we were calculating this in maybe an incorrect way. So we take the multiplication, the result of multiplication, and then add it to start value. Okay, so first year value, second year value, third year value. Okay, we run the code and it's probably going to give us the exact results we're looking for. Yeah, this is something interesting to keep in mind. All right, let's move on to the next thing. Dang, we've been working for a while and we still haven't gotten through this section. We're only at 43%. Translating verbal description into programming language. Okay. Take a look at the code we provided in the editor. It assigns two integer values, manipulates them, and then finally outputs the result in the big result variables. The problem is that the manipulators have been described using natural language, so the code is completely useless now. We want you to... Okay, so this is another one of those... Wait, didn't I do this already? Didn't... Haven't I done this one before? Hold on. No, this just looks very similar to the previous, to like a previous one. Dark mode helps with your eye strain, thanks. Oh, no worries, no worries. I do what the viewers want most of the time. Okay. Okay, so X value and Y value, we got result and we got big result. So they want us to increment X value by 3. So X value, do a barrel roll. I don't know. Wait, I think I might be able to do it with my VTuber. Sorry, my PNG model. Hold on. Let me see if I can do that. Where is that thing? Okay, so this guy right here, let's see if I can rotate him. Huh, there's no, I don't see an option for arbitrary transform. But I can edit transform. Rotation? Wait. Okay, is this doing a barrel roll? 1, 2, 3, 4, like this? 80 Penguin, hello. You did it. Awesome job. All of us, thanks. Are you talking about what time is it? Is it day or night? It's nighttime right now, and it's like 10:41, and we're gonna be closing up shop in about 13 minutes or so. Okay, so what were we doing? We're trying to write out this natural language stuff. So increment X value by 3. So X value plus equals 3. And then decrement Y value by X value. Y value minus equals X value. And then they want us to multiply X value times Y value giving result. Result equals X value times Y value. Okay, and then increment result by result. Result increment by result. Sorry, result. Okay, and next decrement result by 1. Result minus minus. Assign result modulo result to. Assign result modulo result to to Y value. So Y value equals result modulo result, which results in 0. And what's the next one? Increment result by result added to X value. Increment result by result added to X value. So it's result plus equals result plus X value. Okay, and we've got a couple left. Assign result times result to big result. Big result equals result times result times result. Okay, and the last one is increment result by X value times Y value. Result plus equals x value times y value. Okay, so we've got our, how many instructions are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we just need to make sure that the number of operations or the lines of code match. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we can just copy paste this then. And we'll put our code here. Okay, check for spelling errors. I don't think there are any spelling errors. And let's run the code. I think we got the right result. So result equals 38. Big result equals this number here. Okay, great. Move on to the next thing. Okay, finally, we're dealing with characters. So far, we've treated the C language and the computer itself as a tool for performing calculations on numbers. This is consistent with the common belief that the computer is just a smarter calculator, but we know that this isn't true, as a computer can be used for word processing as well. I can't identify all of these characters, so this is either Chinese or Japanese. This is Cyrillic. This is, I'm not too sure what these two characters are supposed to be. This is a, what is this? I'm not familiar with these characters. If anybody can identify them, let us know. Okay, we can define a word as a string of characters, so letters, numbers, punctuation marks. We dealt with these strings during the first lesson when we used puts function to write some text on the computer screen. Japanese, yeah, one of them was Japanese. I think it's Japanese. I mean, it could be Chinese as well, traditional Chinese. Okay. Now, however, we're going to ignore strings consisting of multiple characters and focus our attention on single characters. The problem with processing strings, though, will come back to haunt us when we start working on arrays, because in the C language, all strings are treated as arrays. So let's see. Places everyone. Hello. One is a D in Cyrillic and one is from Icelandic. Which one is from... Is this one, is the left one Icelandic? Or, sorry, is the left one Icelandic or is the right one Icelandic? One of them is Cyrillic. Yeah, I think this is supposed to be the Cyrillic character. And this is also a Cyrillic character, isn't it? Top left. So top left is Cyrillic. Top left, here. Middle is Cyrillic as well, okay. So to store and manipulate characters, the C language provides a special type of data. This type is called a char, which is an abbreviation of the word character. Let's try to declare a variable for storing a single character. So char character looks familiar, doesn't it? Now let's say a few words about how computers store characters. Okay, move on. ASCII code. Computers store characters as numbers. Every character used by a computer corresponds to a unique number, and vice versa. The system of assignment includes more characters than you would probably expect. Many of them are invisible to humans, but essential for computers. Some of these characters are called white spaces, while others are named control characters, because their purpose is to control the input and output devices. As an example of a white space that is completely invisible to the naked eye is a special code or pair of codes which are used to mark the ends of lines inside text files. People don't see this sign or these signs, but they can see their effect when the lines are broken. Okay, and CyberSky, Chinese? Something about a hat? Cyber Sky? Okay, so when we create virtually any number of assignments, we can create virtually any number of assignments, but in a world in which each computer type uses a different character encoding, it would be extremely inconvenient. This has created a need to introduce a universal and widely accepted standard implemented by almost all computers and operating systems all around the world, which is ASCII, the American standard code for information interchange. This is the most widely used system in the world, and it's safe to assume that nearly all modern devices use this code. Okay, no worries, no worries. No worries, CyberSky. Synthesis. Hello, nice to see you here. What is up? Okay, the code provides space for 256 different characters, but we're only interested in the first 128. If you want to see how code is constructed, go to the table on the right. Look it carefully. There's some interesting facts that you might notice. We'll show you one. Do you see what the code of the most common character is? The space. Yes, it's 32. Now look at what the code of the lowercase a is. It's 97. Okay, and let's find the uppercase a. It's code 65. The difference between the code of a and a, so lowercase a and capital A, is 32. Yes, that's the code of a space. We'll use that interesting feature of the ASCII code soon. Note that all letters are arranged in the same order as the Latin alphabet. Proper ASCII lessons. Well, I mean, I guess they're trying to be thorough. Okay, so they're talking about lowercase a and uppercase a. So lowercase a is 97 and uppercase a is 65. So the difference between those is 32. So it's 32. I guess the difference between lowercase b and uppercase b is also 32. Yeah, okay. And all the other ones. Okay, we'll move on. So the car type values. So do we use the values of the car type in the C language? We can do it in two ways, which are not entirely equivalent. The first way allows us to specify the character itself, but enclosed in single quotes, so these apostrophes. Let's assume that we want the variable we want declared a few slides earlier to be assigned the value of the uppercase A. Okay, we do this as follows. So character equals uppercase A in single quotes. You are not allowed to omit apostrophes under any circumstances. Let's assign an asterisk to our variable. We do this as follows. So character equals single quotes asterisk. Does C care about whether or not you use single quotes or double quotes? I think C is a language that cares about single quotes versus double quotes, right? So the second method involves assigning a non-negative integer value that is the code of our desired character. This means that the assignment below will put capital A into the character variable, so character 65. So character 65, which corresponds to the capital letter A, sure. Good question. I am not sure. I mean, let's test out over here. So if we go here and then we define a character and then we try to print it out. So car, we'll call this character, and we'll define this as capital A. And we'll try to print this out. I think printing out characters is it P? Is it percent P or percent C? Is it percent? I don't remember which one it is. And then we'll define character. And then we'll... Oh, okay. It's single quote for characters and double quote for strings. So if we run this, printf Expected something before printf. So printf. Oh, no. We need to. Sorry. Forgot my my semicolon. Character undeclared. Undeclared. Wait, what did I do wrong? Okay, double quote in A is like actually a null character. No assignment. Oh yeah, okay. Forgot to use the equal sign. Silly me. A. Okay, so this works. But if we try to put this into here, double quotes, then initialization, yeah, okay. So when we're assigning characters, we need single quotes. Double quotes doesn't work. But printf, we can use double quotes in here. I guess we'll talk more about it in just a bit, I guess. Okay, the second solution using character 65, it's less recommended, you should avoid it. It's illegible. Without knowing ASCII code, it's impossible to guess what 65 really means. Perhaps this is a code for a character, but it could also be a... It could also happen that a sociopathic programmer uses this devious way to save the number of sheep that have already been counted. The second reason is more exotic but still true. There's a significant number of computers in the world which use codes other than ASCII. For example, many of the IBM mainframes use a code commonly called EBCDIC, which is very different from ASCII and is based on radically different concepts. So the code from EBCDIC is different. So if you write out Texas in EBCDIC, it uses these hexadecimal codes, which is not the same in ASCII. Okay? Sure. All right, so I think we might call it here because it's coming up on 11 o'clock over on my side of the world. But we've got a stream going on tomorrow, so that's going to be at 2 p.m. my time, so 2 p.m. PST. I'm not too sure what that is in your local time. You'll have to look that up. But we're going to be doing some puzzle games. We're going to be doing Crack the Hash, so we're going to be focusing on password cracking tomorrow. So tomorrow we're going to be doing password cracking for 2 of the segments of the stream, and then we're going to move on to an AI course from PicoCTF. So PicoCTF, technically it's Scilab now. Okay, it's only about 8 o'clock in the morning here. Just use that time and keep on going. Yeah, of course. Okay, may I ask what music is running in the background? So this is XCOM 2. I'll type it out. XCOM 2. If you look it up on YouTube, you should be able to find the music there. Oh, they've got streaks? They've got streaks on PicoCTF now. Okay, so the event we're going to be doing is let's see if I can pull it up. Learning paths. And I'm pretty sure they've created a new learning path for AI now. Yeah, AI Foundations. So AI Foundations 1, we're going to be taking a look at this as the main topic for tomorrow's stream. Okay, so what's the premise here? In the year 2030, everybody uses AI, but almost no one remembers how to build it. So this is kind of like a nightmare scenario. We've got advanced technology, but when the advanced technology breaks, we don't remember, well, we don't know how to fix it. But anyways, this looks like a very interesting event slash course, and I would like to take a look at this. Okay, so let's see if we can send you all off to somebody else who's doing cybersecurity stuff. Let's see, infosecstreams.com. I remember a Star Trek episode or 3 that uses that premise. I think I might be thinking of the same one you're thinking of. So this is a good website for learning about different people who do cybersecurity. HackerFrogs, are they online right now? Did they go back online? We got a raid from them earlier. Let's take a look. The AI mission sounds fun. Yeah, so what is... Oh, HackerFrogs is not online. Okay, so let's see who's online over at Twitch. We can send a raid over there. Grey Wolf Medi, hello. Yeah, we'll be doing that tomorrow. So your cyber doctor is on. AI hacking race day 160. Let's see what he's up to. So cyber doctor is a person, I'm not too sure if they're an actual doctor, but they dress as a doctor. Let's see what they're up to. Oh, yeah. Okay, looks like they're doing AI hacking race day 160. So if you haven't checked him out before, he's in cyber insurance. Cyber insurance, really? I didn't know. Let's start the raid. Okay, everybody. When you arrive at your Cyber Doctor's channel, if you could give this message, I'd really appreciate it. OS Frog. Hip Hop Hack. OS Frog. And no worries, no worries. I'm happy to stream for everybody, even if you're just watching me struggle with the C. And give this message when you arrive on the channel. We're going to be streaming again in about how many hours? In about 14 hours we're going to be online again, so get some sleep and then come on back. Alright everybody, HackerFrogs ready to raid in 5, 4, 3, 2, 1. See you next time.